Hello, welcome to Cambridge Answers. Chapter number 1, Life Cycles of Flowering Plants. Exercise 1.1, Flowering and Non-Flowering Plants. Look at the pictures of plants. Which plants are flowering plants and which plants are non-flowering plants? Write flowering or non-flowering in the space below each picture. Non-flowering, non-flowering, flowering, non-flowering, flowering, flowering. Diagram shows the life cycle of a flowering plant. Use the words in the box to help you label the diagram. Seeds, new plant, flower, fruits. Identify and color in the different parts of the flower. Use these colors. Green, sepals. Blue, petals. Orange, anther. Black, filament. The filament is already black. Yellow, stigma. Brown, ovary. Question number 4. These sentences describe the different parts of a flower and their functions. Use the words in the box to fill the spaces below. Stigma, ovary, petals, anthers, stamen, pollen, and carpel. The petals often have bright colors to attract insects. The male parts of the flower are the stamens. They make pollen in their tips, which are called anthers. The female part of the flower is the carpel. It is made up of the stigma, which collects pollen, and the ovary, which contains the eggs. Challenge. Look at the drawing of a flower. Write labels on the drawing for the parts A, B, C, D. Anther, ovary, stigma, and sepals. We have drawn the petals over here as they were missing. Question number 6. Which part of the flower is missing? The petals. Add the missing part to the drawing. That we've already done. What color would you expect the following parts to be? Explain your answer. Part A. The part A is anthers and it has pollen, so the pollen could be yellow, orange, or brown. Part D is sepals, so it will be green. See you next time.
Exercise 1.2, Pollination, Fruits and Seeds. Use the words in the box to complete the sentences about pollination and fruit and seed formation. You will use some words more than once. Wind, insects, seeds, eggs, pollen, stigma, anthers, nectar, ovary, fertilization. The anthers of flowers make a yellow powder. This is called pollen. Pollination happens when pollen moves from the anther to the stigma of a flower of the same type. Some plants use wind to blow the pollen far away. Insects visit flowers to feed on nectar. They get pollen on their bodies at the same time. The pollen and the eggs join together. This happens inside the ovary during fertilization. This is how seeds form. The ovary becomes the fruit. Alia's class investigated a scientific question. These are their results. Color of the flower, number of insects that visited flower. Red 3, yellow 12, white 10, blue 6. Question number 2. Suggest the question that Alia's class investigated. Which color flower do the insects visit the most? Identify the type of scientific inquiry they used in their investigation. Choose from the following types: fair testing, research, observing over time, identifying and classifying, and looking for patterns. Observing over time. Draw a bar chart of the results. The insects that visited red flowers were 3, yellow, 12, white, 10, and blue, 6. Which color flower did the most insects visit? Yellow. Which color flower did the fewest insects visit? Suggest a reason for your answer. Red. Insects do not see red color well. Question number 5. What conclusion can you make from these results? Yellow flowers were visited the most, red the least. What can you do to be sure your conclusion is correct? Repeat the investigation over a long time. Some kinds of flowers have male parts or female parts only. The flowers shown in the drawings have male or female parts. Which is the male flower and which is the female flower? Say how you know. Flower A is the male flower as it has anthers. Flower B is the female flower as it has a stigma and ovaries. Describe the process of pollination in flowers like these. A pollinator will sit on the male flower and collect some pollen. It will then visit the female flower and leave the pollen on the stigma. Draw arrows on the drawings to show how pollination happens. This is how pollination happens. See you next time. Hello and welcome to Cambridge Answers. Exercise 1.3. How seeds are spread. What do we call the spreading of seeds away from the parent plant? Seed dispersal. How are these seeds spread? Sort them into groups and write the names of the seeds in the table. Acacia, mangrove, coconut, impatiens, sycamore, lantana, plum, dandelion, jacaranda, and blackjack. Looking at the pictures, it's very easy for us to put the seeds in the correct column. Eaten. The seeds that are eaten are lantana and plum. The seeds that get stuck on animals are the seeds of blackjack. Fly away. Dandelion, jacaranda, and sycamore. Float. Coconut and mangrove. Explode, impatiens, and acacia. Match the way seeds are spread in the first column with a description of how the seed or fruit is adapted to the way it is spread in the second column. Draw a line from the way the seed is spread to the description of the seed or fruit. Way the seed is spread. By water. Seed has a spongy covering that helps it float. By wind. Seed is very light with papery thin wings. By animals. Seeds have spines and hooks. By explosion. Seed pods dry out and burst open. Describe another way in which plants are adapted to seed dispersal by animals. Give an example. Some plants have fruits that animals like to eat. The animals eat the fruit which contains the seeds. The seeds are spread in the animals' droppings. Why must seeds be spread? So they grow away from the parent plant and have enough space, light, and water to grow into new plants. Challenge. Ahmed and Yasin investigated seed dispersal. They collected 3 different seeds. They dropped each seed 3 times and measured how long it stayed in the air each time. These are their results. Seed 1, single sycamore. Time in the air, reading 1, 9. Time in the air, reading 2, 10 seconds. Time in the air, reading 3, 11 seconds. Average time in the air in seconds is 10. Dandelion, 20, 22, 24. Average time is 22 seconds. Helicopter, 15, 14, 7, and 12. How were the seeds in the investigation dispersed? Give a reason for your answer. By wind. The seeds have wings or a parachute of hairs to help them blow away in the wind. Question number 7. Draw a graph of the average time each seed stayed in the air. Sycamore 10 seconds, dandelion 22 seconds, helicopter 12 seconds. Which seed stayed in the air the longest? Dandelion. Suggest a reason for this. The dandelion seed is carried by a parachute-like umbrella which are made of about approximately 100 bristles. They catch the wind, enhance air drag, and carry the seed. Question number 9. Why did Ahmed and Yasin repeat their measurements? To make the results more reliable. One result for one of the seeds is quite different to the others. Identify the reason and suggest a reason for it. Reading 3 for seed 3. One suggestion could be that they did not start measuring the time as soon as the seed was dropped. Say how Ahmed and Yasin made their investigation a fair test. They dropped all the seeds from the same height.
Exercise 1.4 Seed Germination. Match each word about how seeds grow with its description. Draw a line from the word to its meaning. Germination. When a seed starts to grow. Water. Makes the seed swell. First root. The first part that grows. First shoot. Grows upwards. The pictures of the stages of seed germination are in the wrong order. Number the drawings from 1 to 5 in the correct order. Then write the number of each drawing in the box next to its description. The seed coat splits. The first root grows. The first shoot grows. The first leaves grow. Leaves get better and seeds shrivel. Class 5 investigated germination. They put seeds on a damp cotton wool and placed them into plastic bags. They then put the plastic bags in different places. They checked the seeds after 3 days. This is a bar chart of their result. In which place did the most seeds germinate? Most seeds germinated in the drawer and on top of the desk. How many seeds germinated in the freezer? None. Suggest a reason why the same number of seeds germinated in the desk drawer and on the top of the desk. The seeds in both places had enough warmth and water. The seeds had all the factors they needed for germination. What do the results tell you about the conditions that seeds need to germinate? Seeds don't need light for germination, but they do need moisture and warmth. Arun germinated some seeds. He measured the height of one of the seedlings every 2 days. He wrote down his measurements. Day 2, 10 mm, day 4, 15, day 6, 25, day 8, 35, day 10, 40. Present Arun's results in a table. Remember to give each column a heading. Draw a line graph of Arun's results.
Hello and welcome to Cambridge Answers. Chapter number 2, Sound. Exercise 2.1. How are sounds made? Look at the drawing. Complete this drawing to show what will happen if you tap gently on the jar with a pencil. You will need to draw in the rice grains. Label all the parts of the drawing. When you tap the jar lightly, it makes the rice grains vibrate a little. but you may not be able to see them move. Complete this drawing to show what will happen if you tap hard on the jar with a pencil. Label all the parts of the drawing. When you tap hard on the jar, the rice grains will move. Use the words in the box to complete the sentences. When you tap the jar, it makes the rice grains vibrate. Vibrations travel through the jar and plastic wrap to the rice. The rice grains move less when you tap the jar gently. The rice grains move more when you tap the jar hard. Zara and Sophia listened to the sounds through different materials. This is the bar chart they drew to show how loud the sounds were. Use the bar chart to answer the questions. Is the material through which the sound was loudest a solid, liquid, or gas? A solid. Zara and Sophia listened to the sound through a woolen hat. The loudness of the sound was 3.5 decibel. Draw another bar on the bar chart to show this. We've already done that. Is wool a solid, a liquid, or a gas? A solid. Which kinds of materials on the bar chart do sounds travel through best? Solids. Zara and Sophia investigated how well sound travels through different materials. They listened to the sound of a clock ticking through the materials to see how loud it was. These are the results. Plastic. Distance from the clock in centimeters, 0. Loudness of sound, 4 ticks. Wood. Distance from clock in centimeters, 0. 5 ticks. Water, 2. 1 tick. Air, 0. 1 tick. Cardboard, 5. 2 ticks. Identify the control, independent, and dependent variables. Control variable, the sound from the clock. Independent variable, the material they listen through. Dependent variable, loudness of the sound. Which material did sound travel through best? Wood. Which materials did sound travel through worst? Water and air. Do you think Zara and Sophia's results are accurate? Explain why or why not. No, they did not keep the distance between the clock and the material the same, so this was not a fair test. What should Zara and Sophia do to get a fair and accurate result? Make sure the distance between the clock and the material is the same each time they measure the volume of the sound. Exercise 2.2 Volume and Pitch. Draw a line from each of the sounds shown on the drawings to match its volume. 70, 60, 110, 0, 120. What unit is the volume measured in on the drawing? Decibel. Which of the sounds shown do you think has the highest pitch? Baby crying has the highest pitch. The rock concert may have a higher sound level, measured in decibels, indicating it is louder. However, pitch is related to the frequency of the sound wave, measured in hertz. The pitch of a sound is not directly related to its loudness. In the case of the baby crying and the rock concert, the baby's cry likely has a higher pitch compared to the sounds at the rock concert, even though the rock concert may be louder overall. How loud do you think a Formula One racing car is? Is it quieter than, the same as, or louder than the sounds A, B, and C below? A is quieter than a Formula One racing car. B is the same as a Formula One racing car. C is louder than a Formula One racing car. Marcus and his friends used a rating system of ticks to record the volume of sounds they heard during their lunch break. These are the results. Talking, 2 ticks. Laughing, 3 ticks. Shouting, 4. Music playing, 3. School bell ringing, 5. Draw a bar chart of the results. Remember to give your bar chart a heading and clearly label the bars and the axis. Talking, laughing, shouting, music, school bell. How could the boys have made more accurate measurements? They could have used a sound level meter. Identify the control, independent, and dependent variables. Control variable, the rating system of ticks they use to describe the volume of sounds. Independent variable, the source of the sound they measured. Dependent variable, the volume of the sound. Which sound was the quietest? Talking. How are the vibrations different as sound gets quieter? The vibrations become smaller. Describe how pitch vibrations are different to volume vibrations. Pitch vibrations are fast or slow, whereas volume vibrations are big or small. Zara and Sophia measured the sound volume of a clock ticking through different materials. These are the results. Water, sound in decibel 45, metal 65, wood 60, glass 50, air 40. Draw a bar chart of the results. Which material did sound travel through best? Metal. Explain why sound travels well through this material. Metal is a solid. Particles are close together in a solid, so they bump into each other and vibrate more. Identify the control, independent, and dependent variables in this investigation. Control variable, sound level meter. Independent variable, the material. Dependent variable, sound volume. Write a conclusion based on the data. Sound travels best through solids, especially metals, and worse through air. How could Zara and Sophia get more evidence to support this conclusion? Test more solids, liquids, and gases to get more data. Exercise 2.3, Changing the volume of sound. What is volume of sound? Volume is a measure of how loud or quiet a sound is. Give an example of a loud sound. Thunder. Give an example of a quiet sound. Rustling leaves. How does the bell in the picture make a sound? Someone must make the bell shake from side to side. Then the clapper will bang against the side of the bell. Vibrations travel from the bell through the air to our ears. Suggest as many ways you can think of to make the sound of the bell ring louder. You can write or draw your ideas. Shake the bell harder. My sister's phone beeps all the time when someone leaves a message. How can I make it quieter, Zara? Maybe you could wrap it up in a cotton t-shirt, Sophia. Which material did Zara suggest to muffle the sound of the phone? Cotton t-shirt. List 3 other materials that Zara and Sophia could test. A bubble wrap, woolen fabric, or cotton wool. Write down another piece of equipment they will need to make it a fair test besides the materials to test and the mobile phone. A sound level meter. Name the control variables in their investigation. Explain why they are control variables. The beep/sound made by the phone and the distance from which they measure the loudness of sound. These are the control variables because they do not change. What is the independent variable in the investigation? Explain why it is the independent variable. The material being tested because it changes during the investigation. What is the dependent variable in this investigation? Explain why it is the dependent variable. The volume of sound, because this is what they measure. The volume will depend on the material they're using to muffle the sound. Make a drawing to show how Sophia could use a sheet of card to make the sounds louder. Explain how your idea will help Sophia to hear sounds louder. The air particles inside the cone cannot spread out, so they keep bumping into each other and vibrating. When you speak into the cone, the air particles vibrate more and the sound gets louder. What could you do to improve your design so that it traps more sound and directs the sound better into her ear? If the card is rolled into a cone with the end furthest from the ear as big as possible, it will trap and direct more sound vibrations into the ear. Exercise 2.4. Changing the pitch of sound. Look at the picture of Sophia playing the recorder. Complete the sentences about the pitch of the note Sophia plays. Use the words in the box. When Sophia covers fewer air holes with the fingers, it makes the column of air in the recorder shorter. This makes the air vibrate faster and gives the sound a higher pitch. When Sophia covers more holes with her fingers, it makes the column of air in the recorder become longer. This makes the air vibrate slower and gives the sound a lower pitch. The speed of the air vibrations changes the pitch. The pitch can be high or low. Arun has made a guitar. Look at the pictures A, B, C, and D of Arun's guitar. So far, he has only put one string. Suppose Arun presses on the string at point X and then plucks the string between X and Y. What is pitch? Pitch describes how high or low a sound is. Will the pitch be highest when the string is plucked between X and Y in drawing A, B, C, or D? Explain why. In drawing A, the distance between X and Y is shorter than in drawings B, C, and D. The shorter the string, the higher the pitch. This is because the vibrations are faster in a short string. How will the pitch of sound change if the guitar string is thicker? The thicker string will give lower pitch. This is because thicker strings vibrate more slowly than thinner strings. Zara made the musical instrument in the picture. She fills some bottles with different amounts of water. To play with the instrument, Zara blows across the tops of the bottles. What type of musical instrument is this? A wind instrument. Which bottle, B, C, or D, will produce the sound with the lowest pitch? Explain why. The lower the level of water, the longer the column of air in the bottle. Which bottle will produce the sound with the highest pitch? Explain why. The higher the level of the water, the shorter the column of air in the bottle. Zara wants to put water in the empty bottles A and E. Draw the level of water she must pour into bottle A to make a lower pitch than B. Draw the level of water she must pour in bottle E to make a higher pitch than D. Look at the picture of a drum. How do you think you can change the pitch of the drum? The drum has a skin stretched over the top. You can make the pitch higher by tightening the nuts around the outside of the drum. You can make the pitch lower by loosening the nuts.
Hello and welcome to Cambridge Answers, chapter number 3, States and Properties of Matter. Exercise 3.1, Gases. Look at the picture of a glass of soda. Write the labels for solid, liquid, and gas in the correct place on the picture. Gas, solid, liquid. Use the words in the box to complete the sentences about the states of matter. Solids, liquids, and gases are the 3 states of matter. All matter is made of tiny particles. Oxygen is an example of a gas. A rock is an example of a solid. Vinegar is an example of a liquid. Air is a mixture of gases. Say why this is so. Air is a mixture of gases because it is made up of the gases nitrogen, oxygen, carbon dioxide, and water vapor. You have 12 particles of matter. Draw the 12 particles in each box to represent a solid, a liquid, and a gas. Solid, liquid, gas. Fill in the table to describe how particles move in different states of matter. States of matter: do particles move a lot, quite a lot, or hardly at all? Do particles move apart, move far apart, or shake in one place?
Solid. Hardly move at all, shake in one place. Liquid. Move quite a lot, move apart. Gas. Move a lot, move far apart.
Look at the pictures of particles in two syringes A and B. Which syringe do you think contains water and which syringe contains air? Syringe A contains water and syringe B contains air. Explain your answer using the particle model. In syringe A, there are many particles close together, but not as tightly packed as in a solid. In syringe B, there are fewer particles and they are far apart as they are in a gas. If you hold your finger over the open end of the syringes, which plunger will it be easier to push down? Use the particle model to explain why. The plunger of syringe B. There is a lot of space between the gas particles. When you push down the plunger, the particle can move into the empty spaces. This makes gases easier to compress. Exercise 3.2 Properties of water. Choose the correct answer to each of these questions. Draw a circle around the letter of the correct answer to each question. Which process makes ice become liquid on a hot day? Melting. Which answer shows the process of melting? Solid plus heat gives you a liquid. Which answer shows the process of boiling? Liquid plus heat gives you a gas. Which of the following does not happen when we freeze water? It contracts. Your teacher heats a pan of water. When the water temperature is 100 degrees centigrade, which point has the water reached? Boiling point. Arun put a block of ice on a saucer. Make a drawing to show the ice cube after 2 minutes, 10 minutes. What has happened to the ice? It has melted. Why did this process happen? It melted because the solid ice particles gained enough heat energy to escape from the solid and change into liquid water. At what temperature does this process start to happen? 0 degrees centigrade. What do we call this temperature? Melting point. Sophia's class investigated boiling. These are their results. Liquid, temperature at which liquid boils in degrees centigrade. Pure water, 100. Salty water, 101. Milk, 102. Sugar water, 101. Tap water, 101. What do we call the temperature at which a liquid boils? Boiling point. Which liquid boils at the highest temperature? Milk. At what temperature does pure water boil? 100 degrees centigrade. Does water always boil at the same temperature? How do you know this? No, the tap water, salty water, and sugar water boiled at a different temperature to pure water. Use the results to suggest a reason for this. When we add other substances to water, such as salt, it changes the boiling point of the water. Why can't you cook a hard boiled egg on Mount Everest? You may have to do some research to find out. On Mount Everest, water boils at about 70 degrees centigrade. Egg yolks cook hard at 65 degrees centigrade, but egg whites must reach 85 degrees centigrade before they become hard. So the egg yolk will cook on Mount Everest but not the egg white. Exercise 3.3 Evaporation and Condensation. Underline the correct words to complete the sentences. Evaporation occurs when A. Liquid changes into A. Gas. This happens because the particles gain heat and move faster and further apart until some of them escape from the surface and become a gas. The opposite process to evaporation is condensation. Decide if the sentences are true or false. Mark each one of them as true or false. Evaporation makes wet clothes dry. True. Water disappears when it evaporates. False. Condensation occurs when a gas changes into a liquid. True. Heat makes condensation happen faster. False. Particles must lose energy before they can condense. True. Zara left some cool drink in a bottle on a windowsill. The next day she opened the bottle and saw that the inside of the lid was wet and there were droplets on the inside of the bottle. What liquid formed inside the lid and on the inside of the bottle? Water. Where did the liquid come from? From the cool drink. Name the process that made the liquid form inside the lid. Condensation. Explain how this process made the liquid form. Some particles of water in the drink evaporated. When the particles touched the sides of the bottle and the insides of the lid, they cooled down and became liquid again. Which process is the reverse of the process you named in question number 5? Evaporation. Would the drops of liquid have formed without the reverse process? Say why or why not. No, the water particles would have stayed in the solution/cool drink. The particles needed to evaporate into water vapor and then cool to form the water droplets inside the bottle and the lid. Marcus and Arun investigated the evaporation of water. They placed 2 containers of water on the windowsill. Here are the results. Day, volume of water in container in ml, container A, container B. Day 1, 250, 250. Day 2, 230, 200. Day 3, 210, 160. Day 4, 180, 120. Day 5, 150, 80. Draw a graph of the results for each container of water. Think about the type of graph you should draw. From which container did most water evaporate? Explain how you know this. From container B. There was less water left in the container at the end of the investigation. Why do you think more water evaporated from that container? Container B had a larger open surface than container A, so more water vapor particles could escape from it. Predict the results if Marcus and Arun continue their investigation for another 2 days. Fill in your prediction in the table and add the new points to your graph. Container A 130, container B 50, container A 100, container B 20. Exercise 3.4 Solutions. Arun is writing a report on an investigation. Help him complete his report. Use the words in the box to help you. We wanted to find out if you can get salt back from a solution by evaporation. Method. We dissolve some salt in water in a beaker to make a salt solution. The salt was the solute and the water was the solvent. We left the beaker in a warm place for a few days. After a few days, there was salt in the bottom of the container. There was no water, it had evaporated. Conclusion. We found that we can get salt back from a solution. We do this by evaporating the water. Sophia poured hot water into a glass. She added a teaspoon of coffee powder. She stirred the water. Make a drawing of the glass of water and coffee before Sophia stirred it. Make a drawing of the glass of water and coffee after Sophia stirred it. Before Sophia stirred, after Sophia stirred. Write the labels solute, solvent, and solution on your drawings. Explain what happened to the coffee powder when Sophia stirred the water. The solute, coffee powder, dissolved in the solvent, water. The particles of the coffee powder moved in between the particles of the water, so you cannot see them in the solution. How can Sophia get the coffee powder back? Sophia can get the coffee powder back by leaving the solution in a warm place until the water has evaporated. Marcus has put a teaspoon of sugar into a glass of water to make a solution. He stirred the mixture. After a while, the sugar disappeared. Where has the sugar gone? It has dissolved. How can you test that the sugar is still there? Taste it/evaporate the water. What part of the solution is the water? Water is the solvent. What part of the solution is the sugar? Sugar is the solute. Water and sugar is made up of many tiny particles. We can represent the particles of water and sugar in a model like this. Particles of water, particles of sugar. Use the particle model to draw a picture of the solution Marcus made. Label your particles. Water, sugar. Marcus added more and more sugar to the solution until no more sugar dissolved. Use the particle model to draw a picture of the solution. Sugar, water. Chapter number 4, the digestive system. Exercise 4.1, parts and functions of the digestive system. Label the diagram of the digestive system. Use these words to help you. Mouth, stomach, esophagus, small intestine, large intestine, and anus. Question number 2. Match each of the labeled parts in question 1 with its function A to F listed in the table. Write the name of the part next to its function. A. Pushes food into the stomach, esophagus. Mixes food with digestive juices, stomach. Absorbs water and some minerals into the blood, large intestine. Chews food and starts digestion, mouth. Removes undigested food from the body, anus. Breaks food down into very tiny particles, small intestine. The functions in the tables are not in the same order as they happen in the body. Write the letters of the functions in the correct order. D, A, B, F, C, E. Sophia's group made a model of the human digestive system in this picture. Food, mouth, esophagus, stomach, small intestine, large intestine, and anus. Question number 4. How would you change the model to show the digestive system of a squirrel? Make the small intestine and the large intestine longer, as squirrels have adaptations in their digestive system to efficiently extract nutrients from nuts and seeds, which might include longer intestines. Class 5 investigated digestion in the mouth. They mixed some cooked rice with iodine solution in 2 beakers. They added 20 ml of saliva to the mixture in one of the beakers. They added 20 ml of water to the mixture in the second beaker. They observed the 2 beakers over a period of 2 hours. Suggest a question that Class 5 was investigating. Does saliva break down starch in the mouth? Draw a picture of 2 beakers at the start of the investigation. Label your picture. We have water, rice, beakers, water with saliva, and then rice. We're going to put an iodine solution in it, and which will change the color of the water. Explain your drawing. 2 beakers with cooked rice. One beaker has water in it. The second one has water with saliva mixed with it. An iodine mixture is added to both the beakers. Question number 7. Why did the learners add saliva to one beaker and water to the other beaker? To test whether saliva breaks down the starch in the rice. Why did the learners observe the beakers over a period of 2 hours? To allow time for the saliva to act on the starch in the rice and break it down. Draw a picture of the 2 beakers after 2 hours. Label your picture. The saliva in one beaker broke down the starch in the rice. This made the iodine solution change color back to yellow-brown. There was no breakdown of starch in the other beaker because it did not contain saliva. So the iodine stayed blue-black. Exercise 4.2, Balanced Diets. Tick the true or false box for each of these sentences. A balanced diet gives us all the foods we need to grow and be healthy.
True. Proteins build the body. True. We should eat as much sugar as possible to give us energy. False. Vegetables and fruits contain vitamins and minerals our bodies need. True. Look at these pictures of different foods. Circle the foods that contain carbohydrates in yellow: chocolates, bread, noodles, brown rice, and cookies. Circle the foods that contain proteins in red: eggs, fish, and chicken. Circle the foods that are fruits and vegetables in green: green beans, watermelon, and tomato. Circle the foods that contain mostly fats in black: fried chips and cooking oil. Circle the foods that contain mostly fats in black. We've already done that. Name two foods in the picture that contain fiber: brown rice and green beans. Which foods in the pictures should you not eat a lot of? Fried chips, cooking oil, chocolate, and cookies. This is a picture of Arun's lunch. Is this lunch a balanced meal? Say why or why not. No, there are too many carbohydrates, sugars, and fats in his lunch. There are no vegetables or fruits or proteins or dairy foods. Suggest a meal for Arun that will be more balanced. Draw your meal ideas on the balanced plate and in the glass below. Label each food group on the plate: protein, vegetables, grains, fruits, and dairy. Challenge. We have 2 cans, beans with tomato sauce, and tuna in water. List the different food groups found in the can of beans: protein, carbohydrate, fat, and fiber. Explain why you need to eat foods containing proteins for growth and building up the body. Beauty ate 100 grams of beans. How much protein did he eat? 4.4 grams. B. How much carbohydrates did the beans contain? 16 grams. Beauty's big brother ate a whole can of beans. How much carbohydrates did he eat? 100 grams contain 16 grams. Therefore, 400 grams contain 16 multiplied by 4, 64 grams. Which can contains most protein per 100 grams? Tuna. Which food contains the most salt? Tuna. Which of the foods would be best for Beauty to eat before he plays a game of football? Say why. The beans. They have more carbohydrates which give us energy. Which food is best for building new cells in the body? Say why. The tuna. It has more protein which helps to build up the body. Which food is best for helping food move easily through the digestive system? Say why. The beans. They have more fiber. See you next time.
Chapter number 5: Forces and Magnetism. Exercise 5.1: Gravity, Normal Forces, and Applied Force. What type of diagram is this? A force diagram. Name force A. Gravity. Is force A a pulling force or a pushing force? A pulling force. Name force B. Normal force. Is B a pulling force or a pushing force? A pushing force. Look at the picture. Complete these sentences about the picture. Marcus hits the cricket ball. This is an applied force. Make this drawing into a force diagram. Draw the two forces acting on the lizard. Show the directions the forces are working in. Label each force. The forces are gravity and normal force.
Question number 8. Which picture A or B shows a pulling force? Picture A. Which picture, A or B, shows a pushing force? Picture B. Explain why both pictures show an applied force. The person is applying force on the weights by pulling or pushing. Draw a force diagram to show the two forces acting on a box on a table. Remember to draw arrows to show the direction the forces are acting and label the forces. Normal force, gravity. Question number 10. In each of the following pictures, A and B, describe what the person is doing. Identify the force as a push or pull force, or both. Explain why it is an applied force. Picture A. The person is pushing a wheelbarrow. B. A pushing force. C. The person applies force on the wheelbarrow by pushing it. Picture B. The person is raking up leaves. B. A pulling force. C. The person applies force on the leaves by pulling. Exercise 5.2. Gravity and satellites. Answer questions 1 and 4, 1 to 4 by completing the sentences. What is a satellite? A satellite is a body which orbits a larger body in space. What type of satellite is the moon? The moon is a natural satellite of the Earth. What type of satellite is a communication satellite? A communication satellite is an artificial satellite. What force of attraction exists between the Earth and the moon? The moon and the Earth are attracted towards each other by the force of gravity. Look at the diagram. Which force line, A or B, shows the force of gravity that the Earth exerts on the moon? A. Why is A a thicker arrow than B? The Earth is bigger than the moon, so it exerts a larger force of gravity. Question number 6. What is a natural satellite? A natural satellite is a body in space that orbits a large body. Give an example. The moon. What is an artificial satellite? An artificial satellite is also a body in space that orbits a large body, but it is made by people. Give an example. International Space Station, weather satellite, communication satellite. Complete the diagram of an artificial satellite orbiting the Earth. Draw a force arrow to represent the force of gravity between the Earth and the satellite. Draw a force arrow to represent the force of gravity between the satellite and the Earth. Explain why you drew one arrow thicker than the other. The Earth is bigger than the satellite. This means the Earth exerts a greater force of gravity on the satellite than the satellite exerts on the Earth. Question number 10. What type of satellite is shown on the diagram? An artificial satellite. Question number 11. What launches the satellite into space? A rocket. Why is it necessary for the satellite to travel over 37,600 kilometers per hour when it leaves the surface of the Earth? So that it can overcome the force of Earth's gravity. When the satellite travels at 27,200 kilometers per hour, what is the path that it follows? An orbit around the Earth. What force keeps the satellite following this path? The force of gravity of the Earth pulling on the satellite, and it must maintain a constant speed. What happens to the satellite if its speed drops below 27,200 kilometers per hour? It will be pulled back to the Earth by the Earth's gravity.
Exercise 5.3. Friction, air resistance, water resistance, and upthrust. Underline the correct alternatives to complete these sentences. Friction is a force between two surfaces that are trying to slide past each other. Friction only acts on moving objects. Friction always works in the opposite direction from the direction the object is moving. Friction slows down the moving object. Water resistance slows things down that are moving through water. Air resistance slows things down for things that are moving through air. Look at the picture of the log in the water. Label the two forces A and B acting on the log. Gravity, upthrust. The drawing shows two people jumping with parachutes. Which parachute, A or B, will fall faster? B. Explain why. Parachute B is smaller, so it will not create as much air resistance as parachute A. With less air resistance, the parachute will fall faster. On the drawing, draw and label the forces acting on the parachutes. Show the directions in which each force acts. So the forces are gravity and air resistance. Do you think the parachutes fall faster or slower when the person is heavier? Faster. Explain why. The heavier the person, the greater the force of gravity. How could you test this idea? Make two identical parachutes. Attach a weight to each parachute. One weight must be heavier than the other. Drop the parachutes from the same height above the ground. See which parachute reaches the ground first. Look at the picture of a dolphin. A dolphin can move very fast through the sea. Give two reasons why it can do this. The dolphin has a streamlined shape. It has smooth skin. Exercise 5.4 Multiple Forces. Draw a circle around the correct answer for A to C. Force A is friction. Force B is gravity. Force C is normal force. Name another force that will slow Arun down on a windy day. Air resistance. What must Arun do to overcome the force you named in question 2? Pedal faster. Look at the picture of a lorry. Lorries travel long distances on motorways. Which force slows down these lorries because of their size? Air resistance. How do you think the design feature marked by the arrow helps the lorry to travel faster? This design feature gives the lorry a more streamlined shape. The lorry can overcome the air resistance and go faster. How do you think the design feature marked by the arrow helps the lorry to save fuel? If air resistance is reduced, the lorry does not have to use so much fuel to travel at the same speed. On the diagram, label the four forces that act on an aeroplane when it is flying. So the forces are lift, gravity, thrust, and drag. Which two forces are natural forces? Gravity and air resistance or drag are natural forces. Which two forces are provided by the aeroplane? The aeroplane's wings provide lift and the engine provides thrust. People got their ideas from birds flying when they designed aeroplanes. Look at the drawing below. Label the forces. The forces are lift, gravity, air resistance, and thrust. Which forces are natural forces? Gravity and air resistance are natural forces. How does the bird overcome these forces to be able to fly? The bird flaps its wings to move forward. Look at the picture of the person swimming. Draw and label the four forces acting on the swimmer. Name the three natural forces: upthrust, gravity, drag, water resistance. What does the swimmer have to do to overcome these forces and move forward? The swimmer uses their arms and legs to create thrust for moving through water. How do swimmers make themselves more streamlined? The swimmer can wear a wetsuit, a cap, which have smooth surfaces. They should try to avoid splashing. Exercise 5.5 magnets and magnetic material. Tick yes if the object is made of magnetic material. Tick no if the object is made from non-magnetic material. Cast iron pot. Yes. Rubber gloves. No. Wooden spoon. No. Wool. No. Steel paperclip. Yes. Plastic bottle. No. Aluminum pot. No. Gold rings. No. Rubber tire. No. Plastic bucket. No. Brass candlestick. No. Iron nails. Yes.
Question number 2. Your grandma drops a box of pins on the floor. Describe how you could help her pick the pins up easily using a magnet. Hold a magnet above the pins and they will be attracted to the magnet. Why does the magnet pick up the pins? The pins are made of steel, which is a magnetic material. The magnet attracts the magnetic material. There is a mixture of iron nails and wood shavings on the floor of a workshop. How can you get the nails out using a magnet? Hold a magnet above the nails and the wood shavings. The nails will be attracted to the magnet. The wood shavings will not be attracted to the magnet. Why does the magnet pick up the nails? The nails are made of iron, which is a magnetic material. The magnet attracts the magnetic material. Why doesn't the magnet pick up the wood shavings? Wood is not a magnetic material, so the magnet does not attract the wood shavings.
A compass has a magnetic pointer or needle that is attracted to the Earth's magnetic north pole. Zara and Sophia decided to make a simple compass. They used a polystyrene cup and some water, a cork, a sheet of A4 paper and a pen, a bar magnet, a steel needle, a small piece of sticky tape, and some steel pins. Here are the steps they took to make the compass. They wrote the points of the compass N for north, S for south, E for east, and W for west at the edges of the A4 paper. They placed the paper on a flat surface far away from any metal objects. They put a little water in a cup. They placed the cup in the middle of the paper. They stuck the needle to the table with a small piece of sticky tape. They stroked the needle with one pole of the bar magnet. They stroked in the same direction and made sure the bar magnet was well clear of the needle at the end of each stroke. They continued stroking for about 5 minutes. Then they tested to see if the needle was magnetic by trying to pick up paper clips with it. They pushed the needle through the cork and floated it in the water in the cup. They turned the cup until the needle was lined up north-south on the paper. The needle stayed pointing north because it was attracted to the Earth's north pole. Why did they use a steel needle to make the compass? Steel can be magnetized. Why did they stroke the needle with a magnet? To magnetize the steel needle. Why did they test the needle by trying to pick up paper clips with it? Paper clips are metal and will be attracted to a magnet. Why did they use a cork to stick needle through? Cork is a non-magnetic material. Why did they use a polystyrene cup for the water? Polystyrene is a non-magnetic material. Why did they put the compass far away from any metal objects? So that it would not be attracted to anything except the Earth's magnetic north pole.
Exercise 5.6 Magnetic Force. Arun and Marcus had 2 bar magnets. They did an investigation to find out which magnet was strongest. They used a plastic ruler and a metal paper clip to compare the distance from which each magnets attract the paper clip. Here's a table of the results. Magnet 1, North Pole, distance in mm, first reading 35, distance in mm, second reading 28, distance in mm, third reading 30, average mean reading in mm 31 mm. Magnet 1, South Pole, 31, 26, 27, The average mean reading is 28 mm. Magnet 2, North Pole, 51, 46, 53, 50 mm. Magnet 2, South Pole, 54, 49, 52, 52 mm. Complete the table by filling in the average mean readings. Why did they make the 3 readings for each pole of each magnet? To get more accurate results. Why did they use a metal paper clip and not a plastic coated paper clip? A metal clip is magnetic, so it is attracted to the magnet. A plastic paper clip is non-magnetic, so it is not attracted to a magnet. Question number 4. Which magnet was the strongest, magnet 1 or magnet 2? Magnet 2. Which pole of the strongest magnet was strongest, the North Pole or the South Pole? South Pole. What conclusion did Aaron and Marcus make about the strength of the magnets? Magnets have different strengths. The pole of one magnet can have different strengths. Practice. Marcus compares the strength of 2-bar magnets A and B. He has 3 pieces of card 10 by 10 centimeters and a steel screw. This is what Marcus does. Step 1. Marcus placed the screw on a table underneath one piece of a card. He holds magnet A over the card. The screw sticks to the magnet through the card so he can pick up the card and screw with the magnet. He repeats step 1 with magnet B and gets the same result.
Step 2. Now he puts 2 pieces of card between the magnet and the screw. The screw still sticks to the magnet through the 2 pieces of card when he uses magnet A and magnet B. Step 3. He now puts 3 pieces of card between the magnet and the screw. The screw still sticks to the magnet through the 3 pieces of card when he uses magnet A, but when he uses magnet B, the screw does not stick to the cards. Why does the screw stick to the magnet through the card when Marcus holds the magnet over the card? The screw is made of steel, which is a magnetic material. Which magnet was strongest, A or B? Explain why. Magnet A because the screw still stuck to the back of 3 cards. List 2 ways that Marcus's experiment was a fair test. He used the same screw size made of the same material for each magnet. He used the same size and thickness of card for each magnet. Could Marcus have used a cork or a plastic button instead of a screw to test the strength of the magnets? Explain why or why not. No. Cork and plastic are non-magnetic materials, so they would not be attracted to the magnet. Maglev stands for magnetic levitation. Levitation means floating above the ground. Magnets on the track push and lift the train up in the air by 3 to 15 centimeters. So a maglev train floats above the tracks on a cushion of magnetic force. The magnets in the track are extremely strong and very expensive. If a country wants to use a maglev train, they have to build a completely new magnetic track. It's not possible to change an old train track into a maglev train track. Maglev trains float on air, which means there is no friction with the track. This lack of friction allows these trains to reach speeds of more than 500 kilometers per hour. Maglev trains have no wheels. This makes them quieter than normal trains. Maglev trains use 30% less energy than normal trains. What are maglev train tracks made of? Magnets. What keeps a maglev train moving 3 to 15 centimeters above the track? Magnetic force. Give 3 advantages of maglev train compared to a train that runs on metal tracks. Maglev trains travel faster, they are quieter, they use 30% less fuel than normal trains. What is the main disadvantage of the maglev train? It is very expensive to build the tracks. Find out which countries use maglev trains. In 2020, there were 2 maglev trains in use in China, 2 in South Korea, and 1 in Japan.
Hello and welcome to Cambridge Answers. Chapter number 6, Seasons and Adaptation of Plants and Animals. Exercise 6.1. The Earth moves around the Sun. What shape is the Earth's orbit around the Sun? Slight ellipse. In which direction does the Earth orbit the Sun? Anti-clockwise. What is the imaginary line labeled as X? The Earth's axis. Question number 4. What is the imaginary line labeled Y? Equator. How long does it take Earth to complete its orbit around the Sun? 365 and 1/4 days. Find the position of Earth labeled June. Which month will Earth be when it reaches the following points? C. September. B. December. A. March. What is the length of day and night all over the world in positions A and C? 12 hours. Question number 8. Which hemisphere is having summer? Northern. Explain your answer. The northern hemisphere is tilted towards the sun. What will be the length of day at X? 12 hours. What time will sunrise and sunset be at X? Sunrise 6 a.m. and sunset 6 p.m. If you lived at Y, would you need to wear a thick coat outside? Yes. Explain why or why not. It is winter near the South Pole with long hours of darkness. Which month of the year does the diagram represent? June. Challenge. The diagram shows the Earth in 4 positions during its orbit around the Sun. How long does it take Earth to complete one orbit around the Sun? 365 and 1/4 days. On the diagram, color in the area having night on each Earth. We've already done that. In position A, what season are people experiencing in the northern hemisphere? Summer. Explain how you know this. The northern hemisphere is tilted towards the sun. In position C, what season are people experiencing in the northern hemisphere? Winter. Explain how you know this. The northern hemisphere is tilted away from the sun. Question number 16. What is the length of day and night everywhere on Earth in position B and D? 12 hours. On the diagram, label the month that each Earth represents. We've already done that. For how many days of the year will the Earth occupy the positions shown on the diagram? Explain your answer. Only one day. The Earth is continuously moving in its orbit around the Sun. Hello and welcome to Cambridge Answers. Exercise 6.2, Seasonal Changes. Here is some data about sunrise and sunset in Karachi, Pakistan. Complete the table by filling in the length of the day column, then write longer or shorter for each line with a positive sign in the last column. March 16th, the sunrise was at 6:40 a.m. and the sunset was at 6:41 p.m. The length of the day was 12 hours and 1 minute. March 16 plus 1 day, the sunrise was at 6:39 a.m. and the sunset was at 6:42 p.m. The length of the day is 12 hours and 3 minutes and the day is getting longer. March 16 plus 1 week, 6:33 a.m. and the sunset was at 6:44 p.m. The length of the day is 12 hours and 11 minutes. The day is getting longer. March 16 plus 2 weeks, sunrise is at 6:26 a.m. and the sunset is at 6:47 p.m. The day is getting longer and the length of the day is 12 hours and 21 minutes. March 16 plus 1 month, sunrise is at 6:10 a.m. and the sunset is at 6:54 p.m. The length of the day is 12 hours and 44 minutes. The day is getting longer.
March 16 plus 2 months. Sunrise is at 5:48 a.m. and the sunset is at 7:09 p.m. The length of the day is 13 hours and 21 minutes and the day is getting longer. March 16 plus 3 months, the sunrise is at 5:42 a.m. and the sunset is at 7:22 p.m. The length of the day is 13 hours and 40 minutes and the day is getting longer. March 16 plus 6 months, you have sunrise at 6:18 a.m. and the sunset at 6:37 p.m. The length of the day is 12 hours and 19 minutes and the day is getting shorter.
Question number 2. Identify the pattern shown by the data for the length of day between March and June. The days are getting longer. Is Karachi going from spring to summer or from autumn to winter between March and June? Spring to summer. Explain how you know this. Karachi is in the northern hemisphere. In June, the northern hemisphere is tilted towards the sun. Explain the data in the plus 6 months line. This will be September. Karachi will be having autumn and day and night will be similar in length. What is the difference between animal migration and hibernation? Animal migration is when animals move from one region to another in search of food. Animal hibernation describes how an animal's body slows down and the animal becomes inactive for a period of time. Practice. The graph shows the sunrise and sunset times for Doha, Qatar. Answer the questions about the graph. What causes sunrise and sunset? The earth spinning on its axis. What does the height of any shaded part of the graph represent? The length of the day. What pattern does the graph show between January and June? The days are getting longer. Question number 9. In which months do you think Doha has summer? June, July, and August. What causes the pattern shown on the graph? The Earth orbiting the Sun once a year and the tilt of the Earth's axis. Arctic terns. Arctic terns are seabirds which fly about 40,000 kilometers each year. That's about equal to the distance around the Earth. These birds experience summer in the Arctic and the summer in the Antarctic. Chicks hatch in Greenland in the summer. In September, the parents and the young birds fly all the way to Antarctic to feed during the Antarctic summer. They feed on small fish in the Weddell Sea. In April, they return to the Arctic. An Arctic tern can live for 25 years. During its life, it can fly 1,000,000 kilometers, nearly 3 times the distance from the Earth to the Moon. Use the map and the story and your knowledge from the topic to find the answers to the following questions. Does the Arctic tern migrate or hibernate? Migrate. Give 2 reasons why the birds do this. They migrate to have chicks and to feed. During which months of the year are the Arctic terns in Greenland? June, July, and August. Explain your answer. This is summer in Greenland. During which season do they fly south? Autumn. Which ocean do they fly over? The Atlantic Ocean. During which season do they feed in the Weddell Sea? Summer in the southern hemisphere, December to February. Match one of the following adaptations numbered 1 to 4 to each plant A to D. Large leaves that can lose water. B. Tropical plant. Large flat leaves that float on water. C. Water lily/lotus. Needles instead of leaves that do not lose much water. D. Fir tree. Thorns instead of leaves which lose very little water. A. Cactus. Identify each animal E to H. Choose from polar bear, fish, wading bird, monkey. Use the words hot, cold, wet, and dry in your answers. Some answers need more than one word. Wading bird, wet environment. Fish, wet environment. Polar bear, cold environment. Monkey, hot, wet environment. Match one of the following adaptations numbered 1 to 4 to each animal E to H. Long arms and legs to climb up trees, and swing on branches to get food in forest. H. Long legs to wade in water. E. Thick layer of fat and fur to keep warm. G. Gills to get oxygen from water. F.
Hello and welcome to Cambridge Answers. Exercise 6.3. Plants and animals are adapted to different environments. Identify each plant A to D, choose from water lily, tropical plant, cactus, and fir tree. Cactus, tropical plant, water lily, fir tree. We're going to identify the animals as well: wading bird, fish, polar bear, and monkey. For each plant, say what type of environment it is adapted to. Use the words hot, cold, wet, and dry in your answers. Some answers need more than one word. Cactus, hot, dry environment. Tropical plant, hot, wet environment. Water lily / lotus, wet environment. Fir tree, cold environment. Practice. This picture is of an emperor penguin. This animal lives in Antarctica, which is very cold and full of ice and snow. Emperor penguins hunt for fish in the sea. The female lays one egg, the male keeps the egg warm while the female hunts for food. Read about the adaptations this animal has to survive in such a cold, icy environment. The penguin's nostrils take in heat when the penguin breathes out. This warms up the icy air that the penguin breathes in. 3 layers of feathers keep the body warm. The feathers are oily, so the penguin stays dry while it's on land. Flippers for swimming. Streamlined body shape for swimming fast. Layer of fat under the skin to keep warm and to feed off in the weeks the penguin does not eat while he's looking after the egg. Special folds of skin to cover the egg, which rests on its feet. Feet are standing on the ice. They have good blood supply to keep warm. Feet are also strong and help the penguin to swim fast and catch fish. Question number 5. Make a list of adaptation an emperor penguin has to survive in a cold, icy environment. Use the headings below. Keeping warm. Nostrils take in heat to warm up icy air. 3 layers of feather to keep body warm. Oily feathers to keep body dry. A layer of fat under the skin. A good supply of blood to feed. Getting food. Flippers for swimming. Streamlined shape for swimming fast. Strong feet for swimming. Layer of fat to feed off when looking after the egg. Looking after the egg. Special fold of skin to cover the egg and keep it warm. Layer of fat to feed off when looking after the egg.
Adaptations of frogs. Frogs have many adaptations that allow them to live either in a wet environment or a dry environment. Frogs may breathe through their skin or use their lungs. When they are in water, oxygen from water is dissolved into the frog's thin skin. From there, the oxygen passes through the walls. Frogs have many adaptations that allow them to live either in a wet environment or a dry environment. Frogs may breathe through their skin or use their lungs. When they are in water, oxygen from the water is dissolved into the frog's thin skin. From there, the oxygen passes through the walls of the blood vessels into the blood. When on land, frogs are able to breathe through their lungs at the same time as with their skin. The lungs are a much more efficient way for frogs to get oxygen. Frogs can close their noses to prevent taking in water into their lungs when they are swimming. A frog's skin is covered with a slimy substance called mucus. The mucus stops its skin from drying out. Frogs replace their skin weekly by pulling off old skin to reveal new skin underneath. A new skin every week makes sure that their skin stays soft and coated with the protective mucus. Frogs have webbed feet that allow them to move through the water more efficiently. Their strong hind legs help them to swim and leap better when they are on land. They can see very well even in muddy water and in the dark. Use the information in this case study about frogs to complete the table. Part of frog: adaptation in water, adaptation on land. Breathing: can breathe through their skin, can breathe using their lungs. Nose: can close to stop water getting in while swimming. Skin: renewed every week and covered in mucus to stop it from drying out when on land. Legs and feet: webbed feet to help them swim, strong hind legs for swimming. Eyesight: can see well in muddy water, can see well in the dark.